Hello everybody, this is Rudra Pradhan here. Welcome to BMD lecture series. We will continue with the panel data modeling, and that too in the last class we have discussed about this particular concept, that too understanding the panel data structure and the kind of requirement, the kind of objectives, and then we have already highlighted the kind of types of model, and through which we can actually handle the panel data and the kind of business kind of investigation. So, now as per the kind of models discussion in the last lecture. So, what we will do, we will connect with a particular problem, and we like to highlight how panel data can can be used for the predictions and the kind of management requirement. So, now in this problem what we are going to do, so we like to address the issue between cost and output. That too we like to check what is the relationship between cost and output, and that too using the data of 4 companies and 10 different time periods. So, that means it is the annual time period, and then we have 4 different companies, and we like to check which particular company is more effective while studying the impact of output to cost and a particular level of output. So, accordingly our model will be like this. So, our model will be like this. So, this is actually this standard model. So, since there are 4 companies, by default we can actually start with fixed effect model, and as a result we can develop a model here with respect to 3 dummies. So, W2 is the dummy of second company, W3 is the dummy of third company, and W4 is the dummy of fourth company. So, by default W1 is not there because of dummy variable trap, and while when actually W4 equal to 0, W3 equal to 0 and W2 equal to 0, by default the model will take care with respect to the company 1. So, that means technically, so when this 3 will be removed, so then the particular model will be restricted to C equal to CIT equal to alpha plus beta QIT and epsilon IT. So, this is the company 1 structure, and then so when we will actually allow second company to enter, then this becomes 1 and others will be 0. So, that means this particular coefficient will be added to the intercept, and then the impact of cost can be calculated. Similarly, when we will go to the third company, then this will be equal to 1, rest of the items will be 0. So, then alpha alpha plus this value will be coming as intercept, and then rest of the items will be connected accordingly. Similarly, for fourth company, so the impact will be alpha plus the particular coefficient. So, as a result we will have actually 4 different cost structure with respect to a particular level of output. Now, in order to elaborate more in an attractive way, so what will you do? So, C is the total cost function of a company company I at a time t, and Q is the total output of a company I at time t, and WIT is the kind of dummy variables which can be represented as a 1 for a company, and that to I will vary from 2 to 4 and then 0 otherwise. By default that will be taken care by the first company. So, as a result, so we will see how is the particular structure, and then we will connect with the kind of discussions, right. So, the typical structure will be like this. So, now corresponding to this model, so this is the output side, and we have estimated output. So, now here starts with the alpha, and this estimated model alpha is coming actually 16,171, and this is the second dummy variable weightage, this is third variable dummy weightage, and then this is fourth variable dummy weightage, and this is the output slope coefficient. So, now with the particular structures, we like to know which company is the most effective and why. Now, for that we can fix a particular output level. So, that means the interpretation will be like this. If we fix a particular level of output, let us say 1000, then which company is having high cost and which company is having low cost, and as a result we can declare which one is the most efficient and which one is less efficient, and that too with respect to high cost and low cost respectively. So, what will we do here? So, we like to check here what is the kind of farm 1 cost structure, and what is the farm 2 cost structure, and farm 3 cost structure, and farm 4 cost structure, that too at output 1000. So, now in order to simplify, so we can go to the next slide, and then we can get to know the exact structure. Now, what is happening here? So, you can just put here 1000, then the first company impact will be company 1. So, that will be company 1 16,171 plus this will be 1000. So, technically, so this much of output. So, 1119 multiplied by 1000. So, this will be the first one company impact, and the second company impact will be, so this much of 2385 will be deducted, and in the case of company 3 2315 will be deducted. So, as a result so the for the first the company which is more effective will be definitely this one, and then followed by this one, then this one, and then this one. So, this is how the kind of structure which you can actually have in this analysis to justify that at a particular level of output which particular company is more efficient compared to other company. So, as a result panel data can help you a lot to find out the solution, not only to taking the advantage of sample size, but also it is effective to address some of the side objectives, like here we have studied the kind of cost efficiency. Similarly, there is another example. So, the relationship between R&D expenditure and the number of products patented, and so again, so this is actually a panel data structure, and here to address these problems we have taken 45 companies and that to 7 different years. So, here actually company is very high. So, that is why if you use actually fixed effect model, then we allow time should be kind of factor which time period the relationship is more effective, but farm wise impact will be little bit complicated. So, as a result in this case we can actually go for random effect model, because here the the kind of times the cross sectional units are very high. So, as a result so we will see how is the kind of output. So, again with the estimation process, the output, the first is the model kind of representation, and the estimated output will be like this, and this is what the total observations. Again, so the output is showing that there is a significant positive impact, and that too it is the kind of structure called as random effect models. As a result, so here the there is no kind of individual organizational impact. So, likewise, so you can also actually extend this model, and you will find the particular structure again to analyze the relationship between these two R&D expenditure and the kind of patents. So, the particular model can be represented in a different format, and again so that is actually with respect to kind of individual time periods, and again we will go for averaging the kind of structure, and then we will estimate re-estimate again. So, this is also showing actually significant impact, and the impact is also coming positive. So, now that means technically if you analyze, so then it will show that in both the case there is actually positive relationship between R&D expenditure and the kind of innovation. So, now means it gives the signal that and this is a kind of standard technique through which you can actually study the particular impact. And again, so if you go by dummy kind of structure, then again, so this is the dummy part we can integrate again, re-estimate the process, and then you will check whether there is actually significant impact or not, right. So, in this case we are not actually writing in details, but this will actually subsequently come. That means, actually you have to format the dummy structure again, then you have to re-estimate the particular process altogether. So, again actually this is another way we have to represent, and then again we are finding the particular impact is becoming significant and R square is also improving. So, likewise there are many different ways we can actually check the kind of linkage, and then we will see which particular linkage is more effective while addressing the link between R&D expenditure and the kind of innovations, right. So, likewise there are so many examples. So, typically so what I mentioned earlier, so out of several models, which particular model will be effective, so whether you will go for means in this case whether you will go for random effect model or fixed effect model. So, obviously the Houseman test can help you to find out which one is the best fit as per the kind of problem requirement, right. So, these are the various model diagnostics. So, we have actually solve these problems or analyze these problems with the 4 different cases, and every case these are the first 2 cases, and then again these are the later 2 cases, and in all the cases the main variables, that is the kind of R&D expenditure which is coming positive towards innovation. So, that means panel data structure is a very effective tool to highlight the particular issue and come with a kind of solution which is very effective as per the management requirement. In order to highlight more attractive way, and let us go to the kind of spreadsheet, and we will solve the kind of problems, right. So, what I will do, I will take you to the software, and then I will solve the problem. Okay. So, the software, and the data which we have here is actually like this. So, what will you do? I will just collect this data to this particular spreadsheet, and then allow this is a we will take it to panel data, and then proceed. Okay. So, now this is actually spreadsheet, and what we have here. So, this particular software is called as Gretel, and this is a free software like R software, and this is a software through which we can actually solve the particular model. So, if you go to the model, then you will find plenty of options are there, you see here. So, I am making it a bigger, and till now whatever problems we have solved, that is through Excel spreadsheet, but typically the panel data modeling. So, Excel spreadsheet will not directly help, but it will help if you actually design in the form of dummy modeling, and then only fixed effect model can be estimated, but random effect models and other kind of models which you can actually solve through Excel spreadsheet. So, that is why standard software, statistical software is highly required here in the case of panel data modeling. We have a various types of statistical software, starting with R, SAS, Tata, eViews, and this is actually particular software called as GitHub. So, this particular software is freely available, and you can download and then work as per the particular model is concerned. So, what will you do here in this particular problem? So, we will address the problem like this. So, let me give the background about this problem. So, we have altogether 6 variables, and that too here information and communication technology coverage, that is with respect to fixed broadband, and then economic growth, urbanization rate, gross capital formation, and trade openness, and foreign direct investment. This is actually macroeconomic environment problem, and here our objective is to predict economic growth subject to all these independent variables like ICT coverage, urbanization, gross capital formation, trade openness, foreign direct investment. We actually, since it is a macroeconomic data, and the sample structure, panel data structure will be with respect to time and country, and we have taken country wise informations and then time wise information. So, what is happening here? So, we will just check the view of the data. So, this is the typical view of this data, and you see here. So, the view of the data is actually, this is a country wise informations, and this is a time series informations. Like we have already highlighted the panel data structure, where I can be constant, T will vary, then T can constant, I will vary. In this case, you see here country is constant for a particular point of time, then time is allowed to vary up to this point. Then again country is constant, then time is varying one point to another point of time. So, now once you club these, then this becomes actually called as panel pool data, and then when we try to extract the cross sectional impact and time impact, then it becomes a panel data structure. So, this is the data overview. Now, we can go to the model and then check how is the typical structure altogether. So, now if you go to the model, we will have a plenty of options, starting with ordinary least square. So, now if you click the ordinary least square, then you allow dependent variable, like we have already discussed in the context of regression analysis, that to Excel spreadsheet, but here we can actually we can check this particular structure, and let us see how it can workable. And then okay, so now this is appearing, since it is actually free software. So, it is creating problems. So, now it is all loaded. So, once you put OK, so this will show you the model outcome. So, now growth is actually affected by these 3 variables, and in both the cases these are all actually coefficients, these are all coefficients. Okay, so these are all coefficients, and then this is the T coefficients, and most of the cases variables are coming significant. So, that means out of 3 variables, 2 variables are statistically significant, and followed by other diagnostic test statistics. So, like R square, adjusted R square, then the some of the diagnostic checks like AIC statistics, HQ statistics. So, that means technically this model is showing something actually good for this particular predictions. However, our requirement is just to see what is the kind of output in the context of panel data. So, now you go to the panel data. So, you have actually plenty of option. What I have already told you, that we have a variety of model in the panel data structure, and the discussion which we have had earlier with respect to fixed model, fixed effect model, and random effect model. So, you can click the fixed effect model and random effect model, and again allow the dependent variable to enter to this particular process, and then and then we check whether the effect is coming actually statistically significant or not. So, now putting actually this okay. So, now we have actually option here fixed effect model and just put ok, then the actually the output box is coming here and you see here. So, in the fixed effect model, so this similar kind of results are coming, and again the first variable is coming significant, while the second variable and third variable is not actually coming significant. So, these are all actually a post hoc test which can justify the validation of a particular model, whether to accept this model or reject the model. So, that means actually this particular technique will help you to to go for the kind of penal data structures, and then you like to estimate the model as per the particular requirement. Again you go to the penal data structure, and the kind of there is a structure called as weighted least squares methods, through which you can also check the particular process. And okay. So, now putting ok, so you will get actually this is the outcome of weighted least square methods. So, the same structure we are actually exploring, and then we are studying the impact of economic growth by all these independent variables. Likewise, we have actually different kind of structure through which you can actually calculate the various procedures. Again, so what will you do? So, I will take you to this particular model, then I will check you the kind of different dummy impact in the process of this particular investigations. Yes, now if you put ok, then you will find plenty of option here, and in fact we like to know the kind of the dummy impact. So, what will go, what will do, you will go to this particular process and then allow to check the dummy. Okay, so now you can put including dummy, then you find out the kind of dummy impact. So, these are the various results, and we will have a plenty of options here. These are all called as different dummy impact, and in the process of this investigation about the economic growth with the different variables. So, that means we have actually plenty of results now, and that too with respect to pool data, then with respect to panel data, and with respect to various dummy impact, and so many so that means technically what I like to say justify that so the kind of panel data modeling is a kind of sophisticated technique which cannot be actually easily handled through Excel spreadsheet. So, we need actually standard softwares through which you can actually do the processing of the data and then connect the problem as per the particular requirement. So, typically what we have actually we have already seen how the results are actually coming through panel data modeling, that too by using pool data structure, then fixed effect structures, random effect structure, weighted least square mechanisms. Then we have also the particular structure called as dynamic panel data modeling. Then again there is a advanced particular structure called as a generalized methods of moments. So, all these techniques are hardcore techniques, and with the standard software that can be solved, but the structure is actually more or less same. So, we like to try to investigate a dependent variable with respect to independent variables, but here the data structure will be just the pool of time series and cross sectional together, and then we are actually trying to explore their relationship, and then we are thinking about the kind of prediction. It is not something actually a difficult task this particular process, but here the idea is that when we are dealing the same problem with the only time series data or cross sectional data, so sample size is not so strong enough. So, this is the first obstacles through which we are looking for the panel data structure, and the panel data by default will increase the sample size, and again while dealing with the particular penal data structure through addressing the particular problem, we can actually simultaneously study the individual cross sectional impact and individual time series impact. But when you have actually big data and big cross sectional units and big time series unit, so the individual cross sectional impact and individual time series impact is not so important. So, what is actually important is the effect of independent variables on dependent variable. So, so the requirement is actually to understand the particular data structure and pick up the problems that need to be investigated, and then you adjust the data as per the particular estimation requirement, whether it is actually with respect to pool data structure or penal data structure. But in fact, actually when we are dealing with Excel spreadsheet, so you just connect the data structure as per the penal requirement only. Then you take this data to standard software, and then software will help you to give the kind of statistical output. So, once you get the statistical output, the standard discussion is as per the particular requirement. So, that means the problem which you have already discussed here, the particular case, these are all actually estimated through kind of penal data process, but only thing actually if it is a small kind of structure, then it is easily handled through kind of an Excel spreadsheet, that to only a fixed effect model. But for advanced kind of structure, so you are bound to go to the kind of advanced softwares, and ultimately the idea is we need actually statistical output through which you can address the problem and then come out with a kind of solution which can help you a lot for the management requirement, right. So, that means technically till now whatever we have discussed, starting with dummy structure, then the kind of the use of cross sectional data, the use of time series data, then finally the penal data structure. So, these are all actually various kind of predictive analytics tools through which you can actually solve some of the business problems, where every time the idea is to predict the dependent variable with respect to independent variables. In fact, in between actually in the penal data structure, so many additional tools are there, but ultimately depending upon your problem and the kind of objectives, we can actually connect and then we will go for the estimation. So, ultimately end of the day the model should be very effective and free from all kinds of errors, starting with multicollinearity, autocorrelation, heteroscedasticity, and all other diagnostic checks. Sometimes when we are dealing with actually a penal data modeling, that too the use of more cross sectional observations, time series observations, then there is a lag variables involvements, that is the concept called as dynamic penal data, and in that case so the choice of lag length is also an issue while addressing the problems and for the kind of predictions. So, what is the kind of structure of choice of lag length, how you have to optimize all these structures. So, these are all we can discuss in details, and that too in the next lecture, while we are addressing time series modeling in a kind of different approach. With this we will stop here. Thank you very much. Have a nice time.